So what is a plane wave? What I told, I think all of you have remembered. So wave is nothing but transporting some energy or information, correct? So intensity, if I say in the middle point, it is higher. So if you go from that instant to a some distant point, your intensity will reduce, right? Longitudinal plane wave, I told. Transverse plane wave also I told. Longitudinal means like a drum, vibration, mechanical wave. I'm not discussing all these things. So already we have traversed. We have done. Another one is transverse wave. Correct? Transverse means it is perpendicular to the direction of the wave propagation. Correct? So this thing I have given some notes also. You follow that one. And uh, I think all of you remember this thing. But still, I will, before starting that wave propagation, so if I write, just I'm telling some forms. E equals to E naught. Please, e to power alpha z cos of, already we have covered, but still I don't know after skill lab and all, you have how much you have remembered. That's why I am telling. Huh? So this thing is very important. This is your wave equations. So this is a electric field, correct? So this is called your amplitude. Just I am telling you. If you have remembered or not, I don't know. Alpha is what? Your attenuation. Attenuation in Napier per meter, or in dB also, sometimes it is written. Okay. Uh, okay. Now, can anyone tell me in which direction the wave is propagating? That is your AK cap. In which direction? Write in the chat box. And in what is AE? These two things you tell me. So what I told, if minus Z is there, so your AK will be plus AZ, correct? Your AE is anyhow it is AX cap. Now what will be your AH cap? That also I told. Can anyone tell me what will be the magnetic field direction? Okay, this is very simple. Magnetic field direction, anyone tell me what I told how to do? Then I will do. What I told, your pointing vector P is nothing but E cross H. This thing you need to remember, right? This is nothing but your AK cap. What is your pointing vector? Pointing vector is the direction of wave propagation. Already I told in the class. Direction of wave propagation. Okay. So this is your A cross H. This thing you remember. Correct? Now, if you know this thing, you can easily draw the diagram. I think you can easily draw the diagram. How to draw the diagram? In different, here I'm drawing. Let's say this is AH. I think all of you are following. This is very important. AK. So what I told, P is E cross H. P is this one, correct? So E cross H, in which direction it will be? In this direction, yes or no? So this will be your direction. So what I can write, AE cross AH is your AK, correct? So this will be your AK. And this will be what? AH and AK, this will be your AE. In this way you do. AK and this one is will AH. So if you know this thing, you can easily answer the question, correct? Now what I asked, AH. AH is this one. So what to do? AK cross AE. So AH is nothing but AK cross AE. So what will be your AK? AK is nothing but your which direction? Z direction. So Z cross your X. So Z cross X is nothing but your AY. So very simple. Z and X is your AY. This thing you know. Someone has answered. Okay. Minus Y. Z and X. Correct? X, Y, Z. Z and X. No. So look here, Z and X is your Y. AK cross AE. AK cross AE. Is it clear, everyone? AK cross AE, not AE cross AK. And both are positive. So it will be AY. Any confusion? You can write here. Someone written minus, that's why I'm telling. Okay, very good. So this is the thing. Don't confuse, huh? Plus and minus. Now another thing what I told, if there is minus here, if I tell, just you see, if I tell this is minus 10, just I'm telling it was minus z cos of omega t minus beta z, something if I write, let's say ax. So this minus is nothing but your direction is minus. So your AE will be minus 8. So this thing you don't confuse, huh? Plus and minus. Now alpha is your attenuation. Okay. Now one thing I want to say, if I want to plot, if I want to plot your electromagnetic field, electromagnetic means your magnetic field is also there, your electric field is also there. Let's say, look here, this electric field is in which direction? X direction. So let's say this is your X direction. Let's say this is your plus Z direction. And this direction is your Y direction. So what I told, electric field is actually transverse in nature. Transverse means it is perpendicular to the Z direction. So how you will draw? This will be your electric field. Okay, don't confuse. I have given a cos, so it should be here. So let's say this is sine, not an issue. Just I'm telling. So it will be plus Z direction. In this direction, the wave is propagating and your electric field will be transverse. Correct? Transverse to which direction? X direction. Look here. It is perpendicular. It is 90 degree to which direction? X direction. So this is your E vector. Now if I ask you, can you draw the magnetic field? This is your electric field. Okay. Now magnetic field, what I told. Look here. Magnetic field is your plus Y direction, AY. So AY means this direction. This is your plus Y direction. Minus Y will be this direction. Correct? So you have to go from here to here. How to draw? How to draw the diagram? It will be like there. One second, I'm drawing here. So your magnetic field will be like this. Very interesting. All of you please follow because I cannot repeat everything. This syllabus is huge. So this is also transverse in nature. Look, this is also transverse in nature and it is parallel to Y and it is actually perpendicular to Z. Why? Because Y and Z are orthogonal. So here also it is 90 degree and it is moving like that. In this direction it is moving. So this is called your electromagnetic wave, EM wave. Why electromagnetic wave? Because this is also electric field is also there. Here your magnetic field is also there. So magnetic field is moving in Y direction. Electric field is moving in X direction. And the wave is propagating in plus Z direction. So this is represents your electromagnetic wave. And this is also called transverse wave. Already I told transverse and longitudinal wave, correct? So this is your magnetic field in plus Y direction. Now sometimes if I say it is in minus Y direction, so what it will do? It will start from here, opposite. Just if it starts from there, it will start from there. Okay, this thing you remember. Up to this, some problems we have solved, how to get the velocity, how to give the wave equations. I'm not repeating. So directly we will start from Maxwell's equation and in lossy, lossless and free space. These three things we will do in today's online class. So please minutely follow. Again, I'm telling, very simple it is. This type of derivations will come and don't scare. Correct. So it is very simple. If you just follow my tricks and techniques, it is very simple. So first, what we say, we need to know the Maxwell's equation, correct? Already I told Maxwell's equation, you have to remember Maxwell's equation in time harmonic vector field. Already I told what is a time harmonic vector field, correct? So these all are time harmonic vector fields, correct? Why? Because it is omega is there, omega nothing but frequency is there, and it is periodic in nature, it is dependent on time, correct? And it is a field, electric field or magnetic field. That's why it is called time harmonic vector field, and it is vector quantity. Okay, so this thing you know. So first of all, we will start from del dot D. We know this is nothing but rho V. Still, I am writing all these things. B is nothing but 0. Del cross A is nothing but what? Minus del B del T. I am actually revising also because I don't know you have forgotten or not. I don't know. Del D del T. So these things you know. Now, if I say you write in form of time harmonic vector field or in phasor form. Phasor form. Already I told what is a phasor form. Where there del dot del T, just remember this thing. Where this thing is there, you will replace by j omega. And your vectors, let's say this is a vector, these all are vectors, correct? So what you need to change? These all are vector quantity, correct? You need to change all the vector. Please remember these 2 points into you write B of S, H of S like that. This S will come, correct? Already I told this thing B of S, H of S. So E will be replaced by E of S, H of S, J S like that. Now you change all the equations. What to write? So del dot ds is equals to 0. Del dot bs, I am writing now in the form of a phasor. Okay. And already I told how to change a time harmonic vector field to a phasor form and all these things. You represent by real quantity, omega and all, j omega t will not come because phasor is nothing but uh, a complex quantity divide of the time field, correct? So del cross Es. Now you see del cross Es, what you will write instead of minus del D del T, can you write j omega Bs? Okay, I think all of you are following. Del cross Hs is nothing but, let's say, Js plus j omega ds. Now we will play with all these things. Just you remember why I am doing and how I am doing. These two things you remember. So I think it is clear, everyone, how I have written all these things. Now we will modify this equation. You modify this equation. Now you see, all of you please follow what I am telling now, very minutely. Electric field is there. Here, magnetic field is there. Magnetic field in intensity is there. Here, displacement vector is there. Correct? Now, in any type of wave propagation or maybe wave equation, whatever lossy, lossless, you will start the derivation either from this equation or from this equation. But please remember, you have to form one equation, correct? Here electric field is there. Here BS, look here, ES and BS is there. Here HS and DS is there. So you cannot form a generalized equation. So what to do? Either you convert this BS to HS or DS to ES. Why I am telling? Because if you start from ES, here BS is there, correct? So this BS and this HS is closely related, correct? Can you change this equation so that it will form 4 variables to 2 variables, correct? Here ES, BS, HS and DS are there. So 4 variables are there. So we have to form one generalized equation. So instead of BS, we will write minus j omega. What we will write? Mu into H of S. Here JS is there. What we can write? Sigma into ES plus j omega epsilon into ES. This is cross of Hs. Now you see, all the equations we have transformed into two variables, one ES, one HS, again HS and ES. So again, I'm telling you, you remember all these four Maxwell's equations. After that, you play whatever I am doing now. I am writing in Fraser form. So Fraser means del t will be transformed, will be replaced to j omega. All the vector fields you will write in form of ds, bs, es like that. Correct? Now what I told, you have to form an equation. Correct? So what you will do here, this is electric field, this is magnetic field. So we have to change either from bs to hs and e of s. Why? Because four variables or five variables are there. So you cannot form a common equation. So now we have changed this equation. Correct? I hope all of you are following. Okay. So now I am writing the equation. And another one thing I want to say, these two equations are not required. Anyhow, you remember this is for Gauss law. This is what I told, magnetic field dipoles are not there. So this is the Gauss law for magnetic. This is the Gauss law for electrostatics. Okay. So all these things you remember, but mainly these two equations you remember, the third one and fourth one for forming the equation. While you are doing for wave equations, while you will formulate something on lossy, lossless, whatever we will do now, everything you do in respect of these two equations. So I am writing again these two equations, del cross ES. Okay, I am not writing this phasor form. This phasor will not be there. Okay, is nothing but what I told, minus j omega, wait, minus j omega mu into h of h. This is one equation. Second one, del cross hs is nothing but sigma into es plus j omega epsilon into es. So we can write like that, sigma plus j omega epsilon multiplied with es. We can write yes or no, tell me. So these two equations you remember. These two equations. Meeting will end in 10 minutes. Okay, after that I will send another link. Now, up to this is clear, correct? Now I'm writing some media interface. How the wave will behave or how your equation will be transformed if you do for different media interface. First case is free space. Free space. Free space means in vacuum. You remember this thing. Free space means conductivity will be zero. Your epsilon will be epsilon naught. You know all these things. Still I am telling. Epsilon naught, absolute permittivity, absolute permeability. It will be replaced by these things. So if in the question paper you see the wave equation is given in which space, if it is given in free space, you replace this equation by this. So what you will write? Your equation will be del cross ES will be minus j omega mu naught into HS, very simple. And del cross HS, so sigma is 0, correct? So it will be j omega epsilon naught into ES. Like that you change and do the equation. Technique is same. You do this thing. Now second one, what I told, lossless. Lossless dielectric. I hope all of you are following because we will not discuss again in the class. We don't have time also. Lossless dielectrics. So here also sigma is 0. Lossless means your alpha is 0. So we can write alpha also 0. Alpha is your attenuation. Correct? We will discuss again later. And your epsilon will be epsilon r into epsilon naught. Mu will be mu r into mu. Now you know this mu r and epsilon r is nothing but the relative terms, correct? Relative permittivity and relative permeability. And another thing we can say, your sigma Actually, why it is 0? It is very, very less than your omega into epsilon. Now this equation is there, and you see this equation, your sigma is very, very less than omega into epsilon. So your equation will be what? Minus, sorry, j omega epsilon into E. I'm not writing. Huh? Now you change this equation by this thing. Your sigma and alpha is 0. Uh, Third one is lossy, lossy dielectric. Lossy dielectric. Now you see, lossy means sigma not equals to 0, alpha also not equals to 0. Why? Because attenuation is there, and your epsilon will be epsilon r into epsilon naught. Your mu will be mu r into mu naught. Very slowly I am teaching. Okay, if you have any confusion, you can ask any time. Good conductors. These four cases are there in your syllabus. Anyhow, these are the main cases. Any other cases are anyhow not there. Good conductor means your sigma is almost equals to infinity, and your epsilon is your epsilon naught into epsilon r, and your mu equals to mu r into. So these things are there. Another one I can share. This is infinite means what is the meaning? The meaning is your sigma is actually greater than omega into epsilon. Now you see, in lossless case, your sigma is very, very less than omega into epsilon. But in good conductor case, sigma is very, very high, because conductivity for good conductors, you all know, it is conductivity is very high. So you can neglect this term. Now what will be the equation here? Del cross Hs will be sigma into Es. Okay. So this thing will not be there. And what is the meaning? This thing is nothing but your displacement vector. I think already I told that d of A, correct? So this thing will not be there. I will cover very slowly. I will cover everything. So now we will start about lossy dielectrics. Before starting, uh, you anyone tell me up to this is clear or not? I want the response. Then we will start the derivations for lossy dielectrics. Very slowly we will do, and I think it will be clear